Rationalising the denominator is something we often do. So something like that, 4 on root 2. Sometimes we like to rationalise the denominator. Why? Comparison. That is the main reason we do it, is comparison. Remember I just said, we don't know what the square root of 2 is. We don't know what the square root of 3 is. But if I have 5 root 2 and I have 4 root 2, I know 5 root 2 is bigger than 4 root 2. But if I have 1 on root 2 and root 2 on 2, which one's bigger? Took you a while. They're the same, exactly. Hard to compare them when they're like that, when one third's in the top and one third's in the bottom. So when we compare, it's handy if they're both the same. And by convention, we put it on the top of the fraction. And that's pretty much why we rationalise the denominator. There's no reason why it should be on the top. And that's why when I said, what's the sign of 45, some of you gave me the answer 1 on root 2, and you were happy to leave it like that. Because it's the right answer. I mean, there's nothing wrong with that answer. It's still, if you put it in your calculator, you're still going to get 0.707 or whatever it is, 1 on root 2. So we want to make the bottom of the fraction a rational number. The quickest way then is to multiply it by itself. So root 2, and we get 4 root 2 on 2. The 4s and 2s in this case cancel, and we get 2 root 2. Some people will multiply top and bottom by 2 root 5. There's no need. It's only the surd that's causing the problem. The 2 out the front's not causing the problem. So I only have to multiply by root 5 on root 5. And we get 3 root 5 on 10. Now, if you did multiply by 2 root 5, it's still going to work. But you'd end up with something that would then cancel down. Then we get these ones where we have 2 terms in the denominator. That's where we multiply by the conjugate, because the conjugate will create the difference of 2 squares, and the difference of 2 squares will always create a rational number. So we multiply by root 2 plus 1. And on the top, bottom becomes 2 minus 1, which is, of course, 1. And there's our answer. They love questions like this. How often have you seen those? Well, oh, look, they're the same, but one's the conjugate of the other. It's like meant to be tricky or something. I don't know. So the top we get a perfect square, and on the bottom we get difference of 2 squares. All right, there's a refresh of rationalising